Okay, so we're talking about graphs. We've got 4 different types of graphs, visual representations that you need to be familiar with for IGBio. You've got your line graph, your pie chart, your histogram, and your bar chart. Now, all of these come up in IG Maths. Okay, so you should be familiar with, by the time you get to the end of your IG Maths course, how to do all of these properly. The things that come up over and over and over again in IGBio are your line graphs and your bar charts. So these are the 2 that we're going to focus on in this lesson. Okay, working through line graphs and bar charts. We're going to work through sort of general rules for drawing graph. We're going to work through some specific rules for these 2 types. Then we're going to do some examples as well. Something to remember for all of these ones which have axes, the histogram as well includes on this one, is that we're always setting up with the same general pattern. We have our independent variable, with his units on our horizontal axis, and we have our dependent variable with his units on our vertical axis. Okay, remember, your independent variable is the one that you're setting, the one you're controlling, the one you're saying, I'm doing this at X, Y, and Z quantities. Okay, your dependent variable is the one you're measuring. It depends on the independent variable. Okay, so dependent on the vertical, independent on the horizontal. Let us talk about rules for graphs. Okay, we're going to start off with some general rules when you are drawing graphs. So this is in your paper 6, your alternative to practical. We need, might sound basic, but you'd be surprised, a sharp pencil. Okay, you need to be exact and precise when you're drawing graphs. You can't be ooh, maybe it's here, maybe it's there. It needs to be precise. Okay, you also need to be neat. Right, next one. Your axis headings, or the titles of your axes, and units must be exactly the same as in your data table. Okay, third one. You need to label your scale every 2 centimeters. Now, on your paper from Cambridge, that is going to be exact. On your assignments, it's maybe a little bit slightly wonkier than that, okay? But what it works out to, every 2 centimeters is every 10 tiny blocks. Because each one of those tiny blocks is 2 millimeters. So every 10 of them gives you 2 centimeters. Right, next one. We need a sensible scale. So we're going to say it's based on 1, 2, and 5. Okay, so if we're going for ones, we can go 1, 2, 3, 4. Or we could go 10, 20, 30, 40. Or 0.1, 0.2, 0.3. Okay, so it is some sort of multiple of our 1. Or we could go 2, 4, 6. 2,000, 4,000, 6,000. 0.2, 0.4, 0.6. Okay, some multiple of our 2. If we're using the 5, we could go 5, 10, 15. We could go 5,000, 10,000, 15,000. We could go 10. Sorry, not 10. 5, 10, 15, 20, because 10 is a multiple of our 1. So some sort of multiple of 5. And the reason that we're working with these ones is because they link very nicely in with our 10 tiny blocks. So when we're plotting between the values on our scales, we can get exact and precise locations of those plots. Right. We also need to fill the allocated space. When they give you a little piece of graph paper in that paper, they're giving you exactly the amount of graph paper that you need for the question. So don't squish your graph down into one corner, fill it out. Use the space that they made available for you. Okie dokie. So that is all our general rules. We're going to bear these in mind. We're now going to add some more specifics for our line graphs and our bar charts. So we'll do them together so you can see the similarities and differences. Okay, let us start with line graphs. Okay, so here we are starting where we have continuous variables. So things like temperature, things like height, things like rate of bubble production. Okay, they're continuous, then we can use a line graph. So a little reminder, these are the ones that look like this, and we have data points, and we join them together. Okay, so we've got all of those general rules plus some extra specials. We're going to always plot with an X, not a dot. It's not accurate enough, okay? If you have a second set of data that you're putting on the same graph, then you can use a cross in a circle. You don't use a dot to plot, okay? Next one. You're going to either join by, spelling's gone out of whack today, join by hand or ruler. So if it's a straight line, you join with a ruler. If it's a curve, you join it by hand. Okay, we don't want these kind of curves. We want a nice smooth curve. Okay, if you have very scattered data, you might be asked for a line of best fit. And that goes through the middle of your scatter. Again, we're going to do that in maths as well. So we're going to have a lot more detail there. So we can have a line of best fit for very scattered data. And the other thing that we want to bear in mind is, see how my line on here started at the first point and ended at the last point. Okay, that means we're staying within what we've measured. We never extrapolate. Okay, so to extrapolate is to go beyond. So, for example, to go down to 0, 0, but 0, 0 wasn't one of our points. So we don't know that it's 0, it is 0. It could be way up here at 0. If we don't know, we can't assume. So we never extrapolate. Line is only within the points. Okay, so these are line graphs, special editions. Now let's talk about bar charts. Okay, so here we're talking about discrete data. So if you have information on, let's say, height of males and females are discrete. You can't be male and a half. Okay, so here, if our independent variable is discrete, then we need a bar chart, because we can't draw a line and join together males and females. There's no sense behind that, okay? But we could have one bar for males and one bar for females. So that's what we're driving at with a bar chart. So again, little reminder, bar charts are the ones with the gaps between them. And all the bars are exactly the same width. So we are going to use a ruler to draw bars. We're going to be exact and precise with our ruler. Bars must never touch. Because we're dealing with discrete data. And the gaps between them must be even. So if you have a 5-block gap here, you must have a 5-block gap here, and a 5-block gap here, and a 5-block gap here. They must all be exactly the same. If you've got a second data set, you can hatch with them. Okay, but you have to keep that hatching very much within that bar. Don't get sloppy. Okay, so that should be everything. Okay, so if our bars touch, we're looking at a histogram, hey? Remember that one. Okay, right. So that is our basics for our bar charts, basic for our line graphs. Now it is about doing some of these in real life. So while we are pulling that up, we have a question. Will the question in the exam specify what chart it wants you to draw, or is that up to you to decide or figure out? It's going to depend on the question. It's going to depend on the examiner. Okay, so in some cases they will say draw a blah, 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 and you must then draw a blah, blah, blah. If they don't say, you've got to figure it out from the data that you're given. Right, so let us do some past paper questions. I just need to do a new share so you can actually see what I'm looking at. Okay, and when I do that, then it wants to move everything. Okay, give me a moment. Okay, so hopefully now you can see a PDF called Practicing Graphs. So what we're actually going to do is we're going to do the graphs. Okay, so some students investigated the effect of pH on the activity of an enzyme. This enzyme, because we're referring back earlier in the question. Okay, this is part H of the question, so there's a lot that's come before. Their results are shown in table 1.2. Now we've got pH and we've got time for starch to be broken down in minutes. And already we're thinking dependent and independent. Remember when we draw a results table, we always put the independent in the left-hand column. It's the same for when Cambridge draw a results table. This here is our independent. And it makes sense. The time taken for the starch to be broken down depends on the pH of the solution. So this is our dependent, which means that this one is going on the horizontal and this one is going on the vertical. So I'm going to need a little bit more space here. We've got pH going all the way up to 8.5 and we've got time going all the way up to 10. And we have this horrible, horrible grid. Okay, so when the grids are printed on the original question papers, they don't look quite so horrible and often you can pick out your 2 centimeter gaps. Seeing as we're working the hard way now, we're going to count our 10 blocks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, sorry, we're gonna, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, and this is like a bit of a slog, okay? But the thing is that it's worth doing this because then everything's accurate and you're going to get all 4 of those marks. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. Why does it keep doing that? Don't know. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think that's 10. 1, 2, 3, 4. Goodness. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to need glasses after this lesson. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and that often happens. Okay, and it means that I can count to 10 more than once, which is brilliant. So same thing on the vertical axis. It's a lot quicker if you're doing it with a pencil and a ruler as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, hopefully. 1, 2, 3, 4, 5, 6, 7. Okay, I'm losing it here. But I seem to have been able to count again. So here we have 0 at the beginning. Remember we said that our axes labels must always perfectly match. So pH down here. And our dependent is time for starch to be broken down in minutes. And we copy it. Exactly. Why waste a mark when all we have to do is copy? Okay, so we need to go up to 10 on our vertical axis. 1, 2, 3, 4, 5, not going to work, but then it's a good indicator that 2, 4, 6, 8, 10 is going to work. Okay, pH, we need to go up to 8.5 or 9. 1, 2, 3, 4, 5, 6, not going to work. 2, 4, 6, 8, 10, 12 is going to work. And we're going to use basically the vast majority of our grid. Then we plot each point. So 3.5 is at 9. So 3.5 is, well, 3 is halfway between 2 and 4, and 3.5 is then halfway again. So we're 2.5 blocks away from 4, and we're all the way up at 9. Okay, now my need for glasses is getting higher. So when you do this on a pencil and a paper, you're going to do this exactly. Okay, but for now, I have to admit that I'm not going to do it exact. So somewhere there. At pH of 4, we have 7. So 4, then we're halfway between 6 and 8. pH of 5.2, so a little bit after 5, we have a rate of 4. Then pH of 7, obviously I can't count. 5.2 is before 6. 5.2 was 4. pH of 7, we have a rate of 1, so we're dropping right down. Then pH of 8, we have 4.5. So we're going back up. And pH of 10, 8.5. So up again. Now, you can see already, this is not something we can put a ruler through and draw. So what we would need to do is join these neatly plotted, precisely plotted x's by hand with a curve. And it needs to go through each point exactly. Okay, and this is a nice little reminder of enzymes. When we get to the optimum pH, the time taken for the reaction is lower. It happens quicker. Okay, so there is your line graph in action. Okay, we've done our counting our tens, counted our tens. Our labels for our axes exactly match the labels pH of, oh gosh. Yes, okay, all right. And I see we have one awake person. Okay, so the last pH was 8.5 up to 10. I did that one back to front. So there's our 8 and 4.5. 8.5 up to 10. There we go. That's a much better curve. Okay, so obviously my eyes have gone completely squonk. I can't even read a data table, but that's because we're trying to do this on a nasty grid on the screen. So you've got no excuses when you're doing it on paper with a pencil and a ruler. Okay, so we plotted with our x's, we joined by hand for a smooth curve. So given the time, we're going to jump now to a bar chart. Let's do this one. Okay, so some students collected food packaging labels to find the nutrients present in bananas, and table 2.1 is a summary of their findings. And there's your table. And again, okay, you're looking at two things. One, this is my independent, always independent in the left column. This then is my dependent. And here we see carbohydrate, fat, protein, fiber. We can't be carbohydrate and a half. So this here is discrete. And the reason that we're doing this is because we want to make a note. Are we heading towards what type of graph? Discrete data. For our independent, we are heading towards a bar chart. We are then confirmed as we read further in the question, plot a bar chart. So 1, 2, 3, 4 bars, okay, separated bars, and here is our values. So we get to do the same counting to 10 thing. 1, 2, 3, okay, goodness gracious, we don't need to do it that side because there we want to do bars. So 1, 2, okay, we're going to be very dodgy and we're going to guesstimate, which you would never do in your exam and you'll never do in your assignment, and you're promising me very clearly that you're never going to do it. Okay, you are going to count your 10 blockies and you're going to mark every 2 centimeters. Right, so we need to go up to a maximum of 22 and a bit, so we need to go past that. So we're not going to be able to count in 2s. So let's, how about, 1's not going to work, 2's not going to work, so now we're working on 5. So 5, 10, 15, 20, 25, and I guess this is maybe slightly underestimating my 10 blockies because that looks about right to be higher up. Okay, then we need our 4 bars, okay, but we need even gaps. So often I find if we go 5 blocks, 1, 2, 3, 4, 5, then we can get a 5 blocky bar, then we skip 5, then we draw 5 bars, then we skip a 5, there's our 3rd bar, skip a 5, there's our 4th bar. So those look quite skinny and we haven't used a lot of space. So how about we press the right key, okay? So we're going to go skip 5, draw 10, skip 5, draw 10, skip 5, draw 10, skip 5, draw 10. Now that's filling our space. Beautiful. Right, so same things. We have mass, units, grams per 100 grams. We have here, the axis label is nutrients. The data labeled is carbohydrate, exactly what it says. Fat, protein, and fiber. Okay, and then we've got to plot exactly. So 22.25, well, if that's 20, that is 21, that is 22, that's 22.5, so 22.25 is halfway in between there, and that line must be halfway between the bricks, eh? There's our carbohydrate. Yes, he's beautifully straight, use your imagination. Okay, fat, 0.25, well, there's 1, so fat is actually not even, it's like this smidgen of a piece down the bottom. Protein is 2, so he would be like that. with a ruler, 5 at 2.5, so just a bit higher than protein. Okay, so if we've done this accurately and we've done it properly, we're going to get our 4 marks. Okay, so graphs are straightforward if you do them properly. Follow all those guidelines, follow all those rules, be neat, accurate, and precise. So there are another 4 graphs on here, 2 more bar charts and 2 more scatter plots. So if you want to do the practice of those ones, then let me know and I shall send you through this PDF so that you can practice some extra graphs, maximizing those 4 marks. We didn't end up with much time for questions. So if you do have questions, you can send them through on the chat, either to me or to Marie. She'll also be able to answer your questions for these. And then I'll either answer or forward it to her depending on what your question is. Okay, otherwise, have a wonderful Monday. And I shall see you for next week's live lesson. Cheers, guys. You're very welcome.